You want to learn how to build almost anything, like a mobile phone, a portable speaker, MP3 player, a robot, or almost anything you can imagine. Well, then you have to learn how circuit diagrams work. Because circuit diagrams, they tell you how to connect components so that you can connect components in real life and create that specific circuit. And you can find circuit diagrams for anything online. Mobile phones, MP3 players, robots, you name it. Anything you can find online. So, what is a circuit diagram? Let's look at an example. Here we have a circuit with a battery, an LED, and a resistor. And I've drawn this out the way it looks in real life. With a circuit diagram, this would look like this. Here you have the same circuit as on the left, just drawn out as a circuit diagram. So here we have the battery, here we have the LED, and here we have the resistor. And you can see this line here represents the wire that connects the batteries here. This line here represents the wire that connects the other side of the LED to the resistor. And this line down here represents the wire that connects the other side of the resistor back to the battery. So in order to build something from a circuit diagram, all you need to do is to identify the symbols in the circuit diagram and then connect these components just as they're connected here in the circuit diagram with the lines in between the components. So to sum it all up, a circuit diagram is a simple way to describe how to connect components to achieve a specific function. Let's say we have a pipe that is full of water. There's no room left inside the pipe. It's completely full of water. What happens if we push 1 liter or 1 gallon of water in on one side here? Well, if we push water in here, that means that the same amount of water will be pushed out on this side. So if we push in 1 liter of water on the left side, it will push out 1 liter of water on the right side. And the same if we push in 1 gallon of water on the left side, 1 gallon of water is pushed out on the right side. And it's the same with electronic circuits. A wire is always full of electrons, which make up the current. And so when we push current in on one side, the same amount of current must come out on the other side. So the symbol for current is I. So if we have current I going here, and we say that this current is, let's say it's 1 ampere. That means this 1 ampere is also pushed into this resistor here. So we have 1 ampere going through the resistor too, right? And then this 1 ampere is pushed through the LED. So that means we have 1 ampere going through the LED also, which in most cases will break it, but let's just keep 1 ampere as an example. We have 1 ampere going into the circuit here. It goes into the resistor. It goes through the resistor, it goes into the LED, it goes through the LED, and then it goes back here. Still 1 ampere because there's nowhere else for these amperes to go, and it goes back to the battery. So what goes in must come out. Remember the phrase, what goes in must come out? Let's look at how this applies when you have several paths for the current to take. We'll start with these pipes, just to get in the right mindset. Don't get put off by my terrible drawings, by the way. If these pipes are filled with water, whatever amount of water you push in on one side have to be pushed out on the other side too. So if you push in 1 liter of water into this pipe on top here, the total amount of water that comes out of the two pipes on the other side will also be 1 liter. Or if you push 1 gallon of water into the left side of the bottom pipe here, you'll get 1 gallon out on the other side. It doesn't matter how many branches you have in the middle. Whatever amount you push in on the left side will come out on the right side. So, what happens in this circuit if the battery is pushing 1 ampere into the circuit? Well, there are only 2 paths for the current to take. So some of the current will flow through resistor R1 and the rest will flow through resistor R2. Then at the end here, the 2 paths join and the currents join as well. So the current that goes back into the battery will be the sum of the 2 currents from R1 and R2, which is the same amount of current that went into the circuit from the plus from the battery. For some of you this might be obvious, but it wasn't obvious for me when starting out, so here goes. Let's draw a circuit with 2 resistors connected in parallel. Now, what is the voltage drop of resistor R1? And what is the voltage drop of resistor R2? If we measure the voltage over the 9-volt battery, obviously we'll get 9 volts, right? But what if we move it over here, over the resistor R1? You're still measuring the voltage between the same points as before, right? So that means you will also get 9 volts here. What about if you measure over R2? Still the same measurement points, still 9 volts. This is important to know because it's much easier to understand the circuit when you know the voltages of a few key points in the circuit. If you want a super easy way to build circuits, you want to use a breadboard. It's quick, it's easy, and you can easily reuse the components in a later project. A breadboard looks like this, and it has these holes that you can stick components into. And some of these holes have connections between them. So for example, these five holes up here are connected. These five holes here are connected, and so on, all the way down to the bottom. Each hole on each row are connected. So, and on the other side here we have the same. These 5 holes are connected, these 5 holes are connected, and so on. Then on the side here we have vertical connection instead. So all of these holes are connected vertically all the way down, and it's the same with this one on the right side here. They are all connected down here. So that means if you connect something up here, you can connect something down here, and the 2 things will be connected together. And these columns here on the side are usually used for power supply, so that you can connect, for example, the plus and the minus to the top hole here. And then you can easily, if you have a component down here that you also need to connect to the plus, you can just have a little wire from a hole down here over here, and then you have plus here as well. So, and these vertical connections, you have the same ones on the right side as well. So these are also connected all the way down there. So let's draw a simple circuit and see how this can be connected both without and with a breadboard. So here we have a simple circuit with a battery, a light emitting diode, and a resistor. And one way to connect this is to just connect the components together with some wires, like this. And another way of connecting it is like this on a breadboard. So let's look at the connections here and see how it works. And from the schematic here, we can see that the plus from the battery is supposed to be connected to the plus side of the light emitting diode. And here on the left side, you can see the plus is connected with a wire directly up to the the long leg, which is the positive side of the LED. And here on the breadboard, we have it connected to the top row. And since each of these holes here on top row are connected, that means we have a connection from plus to the positive side of the LED, or the long leg. So on the other side of the LED here, we need a connection to the resistor. So on the left here, we have the resistor connected directly to the short leg of the LED. And here on the breadboard, we have the short leg connected down to this row, and a little bit further down on this row, there's the resistor. So that means these are connected here as well. Then on the other side of the resistor, we have a connection back to minus of the battery. And here on the left side, we can see that this is connected with the wire down to minus. And here on the breadboard, we have the other side of the resistor connected on this row, which is connected to all the holes over here. So when we have this wire connected into this hole, we have a connection here between these two, and this goes to minus. So as you can see, these three are all the same circuits. And when you are making much bigger circuits than this, you'll see much more benefit from using a breadboard versus using this where you just connect it with wires, because when you have like 10 different components here, it's going to be hard to manage all the wires going here and there. But on a breadboard, it's very easy because you have these internal connections on the board.